Okay, here we are with our first video with Mrs. Schwartz. Hope you are all doing well. I'm going to be picking and choosing from our book and sections throughout the rest of the year, so I'm not going to be going consecutive, but this section that we're moving into is all about trigonometry. So this will be 8.2 day 1 in your book, and we are going to be talking about the 3 basic trigonometric ratios. So the trig ratios in a right triangle. So let's review the right triangle. Let's go angle B, C, D. And remember, the side across from the 90-degree angle is always called the hypotenuse. And then the two sides that make up the right angle are the legs of the right triangle. So you've got a leg here and a second leg. Now, the 3 trig ratios we are going to be using are sine, cosine, and tangent. I'm sure those aren't too unfamiliar to you. But sine, spelled out fully, is S-I-N-E. We will be abbreviating it, as does everybody, S-I-N. And we do ratios from an angle. So we will either be standing on or referencing ourselves at angle D or B. We will never, ever, ever, ever stand at the right angle. So I'm not going to use B or D for right now. I'm just going to say use letter A for any arbitrary angle in a right triangle. That's not the right triangle. So the sine ratio, and a ratio, remember, is a fraction, so it's picking two sides of this triangle and making a fraction out of them. For sine, you have to pick the opposite leg and then divide that by the hypotenuse. And I will be explaining what opposite leg is in a minute after we get through the ratios. So the next one is cosine. And that will be abbreviated COS for cosine. Again, we have to stand at an angle. And the two sides that make up the cosine ratio are the adjacent leg and the hypotenuse. And then our last trig function is tangent. And that is abbreviated tan. And again, we have to have a reference angle. Now, the two sides for tangent are the two legs, but it has to be the opposite leg over the adjacent leg. And I will be giving you a little mnemonic device to help you know all 3 of these, so you won't be referring back to it. You'll just be able to get these right off the bat. So, but first, before we can move on, you absolutely have to be able to tell the difference between opposite leg and adjacent leg. So, I'm going to show you that right now. If we take the triangle from above, triangle BCD, and like I said, we can have our reference angle be either of the 2 acute angles. So if I am standing on angle D, okay, the hypotenuse is always the hypotenuse, across from the 90. That doesn't move. But opposite and adjacent do move around. So opposite leg will be the leg, if I'm standing at D, when I look across the triangle, the one that's opposite from me will be this one. So this leg over here would be the opposite leg. And remember, adjacent means next to or touching. So the leg that touches angle D is this bottom one. When I go from C to D, I end up touching angle D. So this leg here is the adjacent leg to angle D. So opposites across from, adjacent touches. And my reference was angle D. Now I'm going to move myself. I told you we could stand at either of those two angles. So we're going to move ourselves up to angle B and see what changes. So hypotenuse doesn't move across from angle C. But now that B is my reference, when I look across the triangle, that'll be my opposite leg. So across the triangle is down here. So the opposite leg is now segment CD. Notice it was the adjacent leg here. And then the adjacent leg, if I'm standing on angle B, is this one because it runs into B. So the adjacent leg is right here. Okay, so opposite is across from, adjacent touches. Alright, so now the little mnemonic device to help you remember these three ratios is called SOHCAHTOA. So what did I just say? Let's get this book out of my way. So is spelled S-O-H. Ka is C-A-H. And then Toa, T-O-A. SOHCAHTOA. SOHCAHTOA. So how this helps you is the S stands for the sine function. O stands for opposite leg. And H will always be hypotenuse. So sine is equal to the opposite leg over the hypotenuse, just like we wrote up here. Sine, opposite leg over hypotenuse. So I think you can figure this one out. The C would stand for cosine. A would stand for adjacent leg. And H is still your hypotenuse. So cosine is equal to adjacent leg over hypotenuse. Again, just like we have here, cosine A over H. And then TOA, obviously tangent function, is opposite leg over adjacent leg. So as we go through these trade sections, I would absolutely write SOHCAHTOA across the top of every homework paper so you have it handy. So let's practice picking the right two sides for the ratio. So we'll move into our first example. I think I can fit it here. I'm going to move the triangle around a little bit. Rotate it so it's oriented a little differently. So we've got angle A, angle C, angle B. So, and we're going to have a 7, a 24, and a 25. So it might help you to always find that hypotenuse first. So the hypotenuse is across from the 90-degree angle. Put a little h by it because it's never going to change. The legs, remember, they can flip-flop from opposite to adjacent depending on where I'm standing. So let's go cosine from angle A. So that means we're going to stand on this angle. And cosine, we want the adjacent leg over the hypotenuse. So remember, the leg that's adjacent runs into me. So it's not the hypotenuse. It's either the 24 or the 7. You can see the 24 is the one that's adjacent or touching. So cosine will be 24 over the hypotenuse 25. So we can leave it like that. The book might ask you to write the ratio as a decimal. And that just means you're going to take 24 and divide by 25 and give a decimal for it. So 24 divided by 25, 0.96. All right, let's try another one. Let's take the tangent ratio from angle B. So this is your reference. This is where you stand. So I'm standing on B. And tangent is opposite leg over adjacent leg. So I'm not using that hypotenuse at all on tangent. So opposite from B is across from, so I want 24 over the adjacent leg, the one that runs into it, is 7. There it is as an exact fraction. If the book asks for a decimal, we just take 24 and divide by 7, giving us about 3.43. And I do believe they ask you to go out to the hundredths place, so we always round to that second decimal place. And let's go one more. Let's go sine, and let's stand at angle A. So we're back at A. Sine is the so we want opposite leg and hypotenuse. So opposites across from A will be the 7, and hypotenuse 25. So 7 over 25. Decimal, if they ask for it. .28. And it came out exact. I didn't have to round on those, the first and third one. Okay, let's see what else I have. Okay, moving on to calculator. Nope, exact values. Okay. Use a special right triangle to find the trig ratio. So, example 2 is use a special, and remember we had 2 special right triangles, the 2 that were on the poster in front of the classroom. To find trig ratios. Okay, let's quickly review those 2 special triangles before we get into the example. Well, actually we need them for the example. Let's go with the 30, 60, 90 triangle. So 30 will be across from the short leg. 60 is across from the long leg, and then we have our hypotenuse. And if you remember, all you have to do, if you can remember the ratio of the sides, we called the short leg x. So I'm just going to pick a number there. It doesn't matter what I pick. If I pick, say, 5. Remember, the hypotenuse was double that short leg, so that would put a 10 here. And then the long leg was the short leg times by square root of 3. So maybe I'll put that in terms of x again, so you have those x, 2x, and x times the square root of 3. So for this example, so I'm going to ask you for like the tangent of 30. You have to have a set of numbers on here, and I just arbitrarily picked the 5. You could pick any number you want, and they're all going to reduce down to the same thing. Okay, our other special triangle was that 45, 45. Remember, the legs were the same, which made the angles the same here. And then the shortcut to get the hypotenuse was take that leg and times by square root of 2. So I'm going to arbitrarily pick the side length to be a 2. That puts this leg at a 2, and then the hypotenuse at 2 square root of 2. So now I'm going to ask for some trig values for the either a 30, a 60, or a 45 degree angle. So for example, let's say I ask you to give me the sine of 60 degrees. That means you're always going to stand on this angle. So that means I'm standing here. And the 2 sides that make up sine, remember? It's so. So its sine is opposite leg over hypotenuse. So if this is my 60, opposite is the 5 square root of 3. Hypotenuse is the 10. And I want to reduce if I can, and I can reduce the 5 and the 10 down. 1. So I get square root of 3 over 2. Let's try another. Let's go with the tangent of 45 degrees. So that means my reference is the 45, so I'm over in this triangle. I can stand on either one. It's going to come out the same. And tangent is TOA. So it's the 2 legs, so it's opposite leg and adjacent leg. Well, can't really screw this one up because they're the same. So opposite would be this one. It's this 2 divided by the adjacent 2. We're going to get 1. And let me go with one more just to throw in something you may have forgotten about. Let's go the cosine of 45 degrees. Cosine, our mnemonic device is ka. So I need adjacent leg and hypotenuse standing at the 45. So, adjacent is the one touching. That's the 2. And hypotenuse, across from the 90, is the 2 square root of 2. Okay, if you look, these 2's do cancel each other out. But remember, there's a 1 left in the place when you cancel. So I get 1 over square root of 2. And if you remember, we can't leave that square root in the bottom. We got to hit it with a 1. This is a trick you know. So the top becomes 1 times the square root of 2 over, in this, remember it's square root of 4, because you multiply underneath, and then the square root of 4 comes back to a 2. Just a 2 without the square root. So the cosine of 45 degrees is square root of 2 over 2. And then the last thing we're going to do today is use a calculator to find trig ratios, and this will lead us into our story problems later on. Use a calculator to find trig values. Okay, so the thing about using a calculator, oh, I got off the screen, is you have to make sure it's in the right mode. There are 2 modes your calculator can be in, degrees and radians. And you don't know anything about radians. You definitely want to be in degree mode. I can show you on the graphing calculator, and then I'm going to look for a scientific one here in the room and see if I have one. But on the graphing calculator, you want to press your mode key. And if you look at the 3rd line down, you've got options radian and degree. We definitely want to be in degree. Oh, I'm going to use my phone calculator. That's the other one. So quit. That one's ready to go. I'm going to grab my phone real quick. I'm going to find the calculator on it. Or not. Oh, here it is, calculator. And if you turn sideways, you will get a nice scientific calculator. And right here, you see on mine, it's going to be in a different place on all the phones. It's just going to be searching until you find it. That put me in radian mode. When I hit rad, and I see the degree here, now I'm in degree mode. If you want to be sure your calculator's in degree mode, you're going to type in the sine of 90, and it should equal 1 if you are in degree mode. If you are in radian mode, the sine of, oops, let me clear that out. In radian mode, the sine of 90 does not come out equal to 1. 0.8939, blah, blah, blah. So, somehow you've got to get a calculator, scientific calculator, not a graphing one, just a simple scientific one, and figure out how to get it into degree mode if it's not in degree mode. Alright, because we're going to be doing some story problems and things, and it's going to require you to use a calculator, but not today. So for now, then after you've got that in degree mode, and we'll have some problems just so we know if you're doing them right. If I want the tangent of 11 degrees, if I know the angle, I don't need a triangle. The other examples we were doing, I didn't know what the angle measure was, but I knew the side length. Here's just the reverse. I've got the angle measure, but I don't know the side length. So all I've got to do to get this ratio, and it will only give it to me in decimal form. So that I like it, for me, the tan 11, and hit enter. That's as hard as it is. 0.19 is the ratio as a decimal. If I want the cosine of 32 degrees, it's just a matter of typing in cosine 32.84. Okay, that's all I need you to be able to do right today is identify opposite, adjacent, hypotenuse, and give those 3 ratios, and use a calculator to type in and get a ratio. So, that's it for today.